Hey there, and welcome. Today, we're going to peel back the curtain, or, the plastic casing, on all those gadgets we use every day. We're going to uncover the hidden backbone that makes them all tick.
So think about it for a second. Your TV remote, that calculator sitting in your drawer, your bedside digital clock, what's really inside? What's the one crucial thing they all have in common that connects all the little bits and pieces and lets them do their job? I bet you've seen it before, but maybe never gave it a second thought.
All right, here's our roadmap. We'll start by figuring out what's inside our devices. Then we'll get to the heart of it all, the one-sided foundation. We'll look at the different flavors they come in, rigid, flex, or metal, and see how all the components get attached. We'll even see how they're classified by reliability. And finally, we'll talk about why, in this super complex world, simple is still a powerhouse.
Okay, so that hidden backbone, that unsung hero we were talking about, it's the printed circuit board, or as pretty much everyone calls it, the PCB.
The best way to think about a PCB is like a stage for a play. It's the physical platform where all the electronic actors, the resistors, the capacitors, the chips, are all mounted and connected to each other. But we're not talking about those super dense, multi-layered boards you'd find in a high-end computer. Nope, today we're going back to basics, focusing on the simplest and honestly the most common type of all.
And that brings us right to the star of our show today, the single-sided PCB. You could really call this the bedrock of modern electronics.
So what does that actually mean? Well, a single-sided PCB is pretty much what it sounds like. It's got all its wiring, those little pathways, usually made of copper, on just one side of a non-conductive base. That base is called a substrate. So you have the circuit on one side and the components get mounted on the other. It's clean, it's simple.
And that simplicity, that's its superpower. For tons and tons of devices where the electronics aren't super complicated, like calculators, garage door openers, simple toys, this design is absolutely perfect. It's just so efficient, it's easy to make, and it's incredibly cheap.
So, are all these simple boards created equal? Are they all just the same green rectangle? Not at all. It turns out, depending on what you need them to do, single-sided PCBs actually come in a few different flavors. It all comes down to the material they're made from.
Okay, let's break this down. The one you see most often is the rigid PCB. It's made from a stiff fiberglass-like material called FR4. It doesn't bend. Then you've got flexible PCBs. These are made from stuff like polyamide, and you can literally bend and twist them. They're perfect for when you need to cram electronics into tight or weirdly shaped spaces. And then there are metal core PCBs. These are built on a metal base, like aluminum, for one key reason: to get rid of heat. That makes them a total game changer for things like powerful LED lights that get really hot.
All right, so we've got our stage. We know if it's rigid, flexible, or metal. Now we need our actors, those electronic components to take their places. So how do we get them on there? Well, there are two main ways to do it.
So the old school way is called through-hole mounting. You literally drill holes in the board, poke the little wire legs of the components through, and solder them on the other side. But the much more modern, automated way is surface mount technology, or SMT. And here's the key difference: no holes. The components just sit right on the surface of the board.
And the SMT process is just so cool. It's like a little robotic ballet. First, a screen applies a very precise layer of solder paste, think of it as glue, onto the board. Then, a super-fast robot called a pick-and-place machine zips around, grabbing tiny components and placing them exactly where they need to go on that paste. And finally, the whole board takes a trip through a special reflow oven, which melts the solder, and bam, everything is permanently locked in place. It's incredibly fast and accurate.
Now, besides their physical shape and how you stick stuff to them, PCBs are also grooved by how reliable they need to be. I mean, it makes sense, right? The board in your TV remote doesn't need to be nearly as bulletproof as the one in a jet airplane.
This is super important. Class 1 is for your everyday stuff, general consumer electronics. If it breaks, it's annoying, but nobody gets hurt. Class 2 is a step up. This is for high reliability gear, maybe some professional equipment where a failure isn't good, but it's not catastrophic. But Class 3, this is the top tier. These are for things that absolutely, positively must not fail. We're talking aerospace, life support systems, places where failure is just not an option.
So, after diving into all these details, let's just pull back for a second and look at the big picture. In a world obsessed with more, better, faster, why does this simple one-sided board still matter so much? Here's really the main takeaway.
While you hear all about these mind-blowingly complex circuits with dozens of layers, the humble, single-sided PCB is the true workhorse of the electronics world. It's the ultimate proof that sometimes the simplest solution really is the best one. It's the foundation that so much of our modern life is built on, giving us a reliable, affordable platform for just a massive range of technologies.
And that kind of leaves us with one final thought to chew on. As technology just keeps racing toward more layers, more power, and more complexity, it's worth asking, where else will a simple, elegant, and foundational idea be the next big winner? Something to think about. Thanks for tuning in.